Let us look at rate of change. We can say a rate of change is a rate that describes how one quantity changes in relation to another quantity. If x is the independent variable and y is the dependent variable, then rate of change equals to change in y, also change in x. So say rate of change, say rate of change, rate of change equal to change in x or in y, change in y, also change in x. Uh, for example, yeah, let's let us draw like a linear graph here. That's a linear graph. Um, let's say you have point here and point here. Call this is point A and this is point B, and value here is x1, y1, and this one here is x2, y2. So in order to define this one, we say rate of change equals to y2 minus y1 over x2 minus x1. And this is the same as the slope. If you've done a slope, how to find the slope on a linear graph, this is how you do, and that means the rate of change. Let's say this is y and that one is x. Another way we can say also write as change of y over change of x. So which is the slope? So slope, which is the rate of change, is equal to y 2 y1. So this one will be change of y, and this is change of x, because this one is x1 and this one is x2. This one is x2, and this one here is y2, and this is y1. So you have change of y over change of x. Yeah, and if for very small changes, we can write this one as the same as dy and dx. Yeah, and this one, if you've been doing, if you're doing derivative, we say this is related to derivative. So slope is related to derivative. Finding derivative, it means for finding derivative of a function is the same as trying to find a slope at a certain point, and that's what is dy dx, and that's what we will be doing now. Trying to you are given a function, we are trying to find the rate of that function with respect either to time. Most of the time the rate are related to time, so be dy, let's say dy dt will be like a dy dt, or you can have dq dt. This is charge per time, and this is dy dt, that's for distance, or yeah, it's like dy dt is like distance, like speed, um, and maybe temperature dt. So that's rate. So rate of change related to with respect to time. Let us look maybe three examples to understand what rate of change is. Example one, you're given that the temperature T, Fahrenheit, in a certain furnace varies with time T seconds according to the function t equals to 4.85 t cubic plus 2.96 t. Find the rate of change at a temperature 3.75 seconds. So this is I think that's a little bit mistake. That should be second. Yeah. So 3.75 second. Always when you're given a question, write what you are given. But this one is kind of more straightforward. If we just start with the solution, we say we're given that t equals to 4.85 t cubed plus 2.96 t. Yeah, and in order to find the rate of change, and to say this is a derivative, so that would be dt over dt, where the capital T is temperature and then the small t is time, equals to find the derivative of this one. So this is like you use the power rule. If you remember the power rule, say y, if you are given y is equal to x power n, if you're given a y is equal to x power n, the derivative of that will be dy dx equals, you take n in front of x, then minus n by 1. So that's the power, that's the power rule. So most of these questions you just use the power rule, and then maybe sometimes a chain rule. We see how it all applies with a different type of question. So this one will be if you find the derivative of this one, will be 3 times 4.85, which is 14.55 t squared plus 2.96, because the t here is t power 1, and we know the derivative t power 1, if you minus 1, you get t power 0, which is always 1. So 1 times 2.96 is 2.96. That's why you get this one. You get this this function and this is solution. So dt, now we need to find the rate at that term. So say dt at t equals to 3.75 second will be equal to, you just plug in 3.75 into your equation, 14.55 of 3.75 squared plus 2.96. If you calculate this one, you get 208, and the unit for temperature is Fahrenheit per second. So we say the answer is 2.08 Fahrenheit per second. So that's the solution for example 1. Let's look for example. Let us look at example 2. We're given the charge through a resistor is given by Q equals to 2.93 T cubic minus 3.98 T. Write an expression for the instantaneous current through the resistor. Evaluate T equals to 4.00 seconds. So we're given that one. To solve this one will be the same as the one we did. Just write Q equals to the function are given, Q equals to 2.93 T cubed minus 3.98 T. So what you need to do is to find the derivative of this one. So it will be dq dt, which is equal to current. So the current, for those who are doing electrical current equals to dq dt, which is change of charge to the change of time, which equals to, if you find the derivative of that one, you get 8.79t squared minus 3.998. So substitute, I will say at t equals to 4.00 second, the current will be equals to dq over dt at t equals to 4 second, and that will be 8.79 4.00 squared minus 3.998. And the answer here, you get approximately 137 amps. Yeah. So remember, you are asked to find the expression for the instantaneous current and then evaluate. So the expression here would be this one here we got. So the expression would be I equals to 8.79t squared minus 3.98, and the current, the value of the current equals to 137.7 amps. So that's how you can solve. So the most important here is you have to know how to do the derivative, and that's what we applied here is a power rule. Let us look for another example. Example 3. In example 3, you're given that the current in a 1.0 in Henry inductor is given by I equals to square root of 6.02t squared plus 20.1t. You asked to find the voltage across the inductor at 6.20. Yeah, so what we're given here, you're given I equals square root of 6.02t squared plus 20.1t, and they were asked to find the voltage and the time equal to 6.00 seconds, and voltage, that's what we are asked. And you need to know a little bit the concept of voltage related to inductor. So in order to find the voltage related to inductor, use this formula. We say V equals to L di dt, where L is your inductor, di dt is the rate of change of current with respect to time. So this is the formula you need to remember. Sometimes you'll be given on your formula sheet with some of the instructors, and yeah, and what you do now, what is missing here is just to find the di dt, and then we have our function I is equal to square root of 6.02t squared plus 20.1 and t. So we say I, start here, say I equals to 6.02t squared plus 20.1t, that's square root, everything under square root. This is different from the questions we did previously. Why? Because this is a radical, and in order to find the derivative of this one with respect to t, you need to change a radical into exponential function. I don't know if you remember that if you have, let's say if you have square root of a is the same as a power half. So we change this one into power half. So say I equals to 6.02 t squared minus plus, yeah, plus 20.1 t power half. Yeah, so now you can be able to find the derivative of this one because it's an exponential function. But another challenge is you can not use just power rule directly. You need to use what is called chain rule. And the way chain rule works is like this one. So say di dt equals to take half, that's power half, bring to the front, and everything in the bracket, right? The same they are, like anything on the bracket here, right down. They were there 6.02 t squared plus 20.1 t, but half you have to minus by 1. So if you take a half minus 1 is minus a half. Then everything times the derivative of the inside of the bracket, which is 6, not 6, be 2 times 6 point, be 2 would be 2 at 2 times 6.002. So everything, that one will be times, I'll put it here, times, that will be 12.04 t plus 20.1. So everything here times that one. We can yeah, so that's the IDT, but this negative half, we can rewrite this one, the whole thing. Let's rewrite the way it is. So say di dt equals to a half 6.02 t squared plus 20.1 t for negative a half times 12.04 t plus 20.1. So this one power half, we can put on the bottom as a square. So we say we can, and at the same time we can FOIL a half times 12.04. So the whole thing becomes di dt equals to 6.02 t plus 10.05, because we FOILed this one and that one. That's one you get now you get the whole thing here. Yeah, so this the whole thing here is that after we had the FOIL 6.02 t plus 10.05, everything over square root of 6.02 t squared plus 20.1 t. So now we got almost at the final. What we need is to substitute t equals to 6 seconds so that we can find the voltage by using by using that formula over there. So we say now we say voltage. Say voltage equals to L di dt, and our L, we are given L is 6 seconds. No, Henry. No, time. Yeah, L is, yeah, the Henry is one. Is not is 1 Henry, and the time is 6. So we have here Henry 1, and and the time is 6.00 second. So just a substitute there. We say volume. This one equals to okay. We say this one will be equals to 1.00 Henry. Then have 6.02 times 6.00. Hold this one plus 10.05 all over square root of 6.02. Have 6.00 squared plus 20.1 times 6.00. If you calculate the whole thing, you get voltage now equals, using a calculator, you should get 2.51 voltage. So that's the whole question. It's a little bit long, but I think the challenge, you need to know the chain rule. If you get a radical, know how to work out on your chain rule here. The chain rule, especially here. Use the chain rule. This is chain rule. Use chain rule. Yeah, there's a lot of resources you can use if you need to understand more about a change rate of change, and I hope I have helped you a little bit to understand how to do the rate of change.